Hello and good morning. Welcome to today's webinar hosted by ASE Kalkitech. I'm Midun from the marketing team at ASE, the leaders in grid communication solutions. So today we are going to discuss about SunSpec Modbus. We'll be giving a hands-on overview with our product ASE 2000 test set. We now support SunSpec Modbus Master capabilities in ASE 2000 with the latest 2.34 December release. And we will be explaining in detail about the hows and whys of SunSpec Modbus and its usage in DS systems using our tool. A couple of hygiene points before we start off this webinar. This is going to be a 45-minute session and it will be followed by a 5 to 10-minute Q&A. Please note that this is a listen-only webinar. So if you do have any questions, please feel free to ask in the chat screen. I will consolidate all the questions and have it answered towards the end of the webinar. If in case we are not able to answer every question, we will definitely get in touch with you personally and address all your queries. A recording of this webinar will be automatically sent to all candidate attendees around 48 hours, 24 to 48 hours after this session. We will also be emailing you a webinar participation certificate, e-certificate, in a separate mail. All right, I see a few people already joining in. So without further ado, let me just introduce the host for today's session, Larry Price and Steren Jose. Steren is our product manager and expert with more than 20 years of experience in the industry, specifically around 61850, SEL, substation protocols, of course DNP3 as well, and he has done numerous trainings across the world. And so too Larry Price. Larry Price also comes with 20 plus years of experience, and his expertise is in the DNP3 and substation protocols. All right, great. So yeah, I think that's let's get started. I think we have more people joined in. Over to you, Larry.
Thank you. Darren, can you share the PowerPoint?
Yeah, right now we are in the introduction slide, Larry.
Hang on one second. I'm not seeing it on my side. Apologize for that. I do not see it. It's not.
You may use a local copy, Larry. I think you can proceed with that.
Okay. Thank you for joining us all today. My name is Larry Price. I work for Applied Systems Engineering. I've been involved with ASE since 2016. ASE originally was founded in 1988. 30 plus years of experience with SCADA protocol communications testing solutions. We are the de facto leader in protocol test sets across many geographical regions. The ASE 2000 test set itself supports 80 plus protocols, and we're enhancing and continuing to add support for new protocols today. The test set itself is used for functional testing, design testing, and commissioning, and overall maintenance and operation support in the SCADA and substation environments today. Modes of operation that we support are master simulation, RTU simulation, or field side device simulation, as well as bidirectional monitoring of the communications to and from the master and those outstations. The test set was originally implemented or deployed in the early or late 80s, early 90s, and several enhancements have been made since then. The ASE 2000 test set will support both Standard protocols used today, such as DMP3, Modbus, conventional protocols that you see in utility environments. And it also supports legacy bit protocols, such as Vancom, Conatel, CDC, etc. The present release that we have is version 2.34, which we just came out with, and that is implementing what is called SunSpec Modbus protocol. And SunSpec Modbus protocol is an up and coming protocol that's become the standard for DER installations today. And next slide, please.
Yeah, I think right now we are in the protocol supported slide, Larry.
Sorry,
So do you want to proceed to the next one?
sorry, can't see. So as far as protocols supported, there are 80 plus protocols. You've got Modbus, DMP3, IEC 101, 104, Conatel, Harris. Legacy bit protocols require specific signaling, and we have the hardware support to allow the proper communication across those protocols. As far as byte protocol support, we have specific views that will display user-friendly information as well as the detailed information involved with the transfer of the data frames. ASE 2000 allows you to capture and archive that information as well as share that with your colleagues. And as far as message analysis is concerned, you need not have a license to review those messages, so you can work with your particular vendors of interest and have them download the tool and share that information so that they can interpret and analyze the same information that you're working with as far as what you've captured between the head end and the field side devices. The newest feature, is, as I said, is 2030.5, and it's it's been recently introduced. We don't yet have support for the server side, but I'll let Staren explain that in the upcoming slide. Next slide, please. Oh, Staren,
Yeah.
you care to cover the agenda today? Thank you.
Yeah, I can. Yeah, I can quickly cover the agenda. So I switch the slide to that. So here today we will talk about DER communication architecture. We will see how ASE 2000 can test the meters and inverters. We will also see how ASE 2000 can be used to test the DERMS system at a high level. And we will also cover the SunSpec Modbus Master capability in ASE 2000. We will cover the overview and main features that we have right now in the tool. And finally, we will go through the demonstration of this capability against a simulator, and we can showcase what exactly we have implemented in ASE 2000, how we see it is to use the tool to navigate through the protocol models. So that's the points we are planning to cover.
So as far as terminology is concerned, Staren, can you explain what DER references?
Yeah, DER is distributed energy resources, and it mainly talk about the communication and the infrastructure available with the PV battery. So nowadays you can see several EV chargers in the network, right? So all these EV chargers are mostly powered from wind or solar kind of resources, and in some cases, these EV network might also get uh, kind of power from the normal utility network. So basically, there is a switching mechanism happening between these two sources. So DR in general talk about the renewable side of it.
So how is it that 2035 came into development, and why don't we use standard SCADA substation protocols with DER sites?
Yeah, here DER communication is slightly different from standard SCADA communication. In most of the cases, in SCADA, generally the master or the client make the connection to the remote side or remote devices. And in this case, in 2030.5 or in the DER side, the server listen for the connection so that other devices in the network can connect to it. And also the data traffic is intermittent. Sometimes these devices will update the information like telemetry and go offline for a longer duration and then again come online after some time. So there is more like an intermittent or there is an interval between the communications. And because of that reason, SCADA protocols like DNP3 or even IEC 61950, these protocols are not suitable for DER network. And another capability of DER is the option to send the schedules or controls in the from that terminology. So in SCADA protocol, generally we send latch in, latch on kind of commands, right? And pulse commands in general. But here, most of the commands are in the form of schedules, and that is also requires a different set of capabilities. And because of all these reasons, IEEE 23.5 is considered as a better protocol for site to DERMS communication.
So with SCADA and the substation, as you were alluding to, you have controls and you have masters and RTUs or outstations. What's the master in a DER application?
In the case of DER systems, generally the DERMS will be like a control center monitoring the entire network. And from each sites, there will be gateways reporting the data to the DERMS, and DERMS will also send the schedules to these gateways. And gateways will finally pass the information to the end devices with the protocols like SunSpec Modbus. But in the case of SCADA, as you know, it's mostly RTUs communicating to the SCADA locally, and SCADA in the local station has many capabilities to provide interfaces to the operator and take or issue controls. So that site level or station level function or human intervention is not expected in DR systems. Most of the cases, it's like a control center in SCADA world. Uh, DERMS act like a central system where it monitor multiple sites and send controls to multiple sites to manage the entire system.
So with multiple sites and devices at these with involved with the DER application, how does DERMS communicate with the meters and the inverters in the field itself?
Yeah, here I will switch to the next slide, their communication architecture to answer your question better. So if you look at the top part of the slide, right, you can see meters and inverters sitting in the field, and those will be connected to the site gateway. In the picture, I have shown AC2000 to indicate that it can initiate SunSpec Modbus Master capability. But in reality, this AC, instead of AC2000, you will see something like a site gateway. And site gateway will collect the telemetry data from the meters either through serial channels or the TCP network. And then further, the site gateways will make a secure connection to the DERM system. If you notice the bottom part of the slide, we are indicating a laptop with AC2000 with the IEEE 23.5 client simulation. But instead of that, in a real scenario, you will see the site gateways establishing connection with the DERMS through internet, through secure channels. So you can imagine the DERMS to site gateway is normally 23.5 kind of protocols, and in some cases there will be aggregators in the cloud, and DERMS will be connecting to the aggregators which are sitting in the cloud, and aggregator can establish connections with the the site gateways through different protocols. One of them can be 23.5, or it could be DNP3 or other protocols. And site gateway further will manage the local communication. In some cases, especially in the case of Flex Connect project, there will be a site controller to handle some of the schedules. But in other cases, if there is only telemetry involved, then the site gateways will directly connect to the meters and get the information. So yeah, that's the general communication architecture. And at a high level, ASE 2000 can test the meter communication either through DNP3 or SunSpec Modbus or Modbus. So those are the typical protocols that you will see on the meter or inverter side. And on the other side, to test the DERMS, you can use 23.5 client capability in AC 2000, and it can simulate larger number of site gateways and verify that aggregators and DERMS can handle those incoming communications.
So is there any security involved with the ASE IEEE 2030.5 connection from the client when you're testing?
Yes, there is a standard security infrastructure. It's called PKI, and generally, SunSpec certificates are issued to all the aggregators in the network, so that there is a secure channel from the aggregators to the DERMS. In some cases, site gateways can also act as an aggregator. It will be like an edge aggregator. And in such cases, these site gateways are also issued with the SunSpec certificates, and TLS connections are made across the internet using these certificates to make sure that it's properly handled, the security side of it is properly handled. So yeah, compared to scattered protocols, there is a better secured setup or architecture in DR communication.
Thank you. Can you provide an overview of SunSpec Modbus?
Yeah, sure. I'm proceeding to the next slide. And SunSpec Modbus at a high level provides, it's a layer on top of the standard Modbus protocol. Most of you might be already familiar with Modbus protocol. Modbus protocol generally have the registers, like holding registers and input registers, etc. There is no mechanism to identify a register with a name. So that is the limitation. And in DER, generally the data is categorized into different classes, and there is no way Modbus can support that. So to support this capability, SunSpec came up with the idea of named tags in all the inverters and meters, and these are standard classes. That means if you identify a Modbus register, we automatically know that it belongs to a specific SunSpec Modbus class and has a specific type. So that concept has been introduced, and it is widely used in inverters nowadays. And there are classes, specific classes for telemetry and control information. So some classes are dedicated for telemetry, like currents and voltages, active power, reactive power. So that informations are categorized into a telemetry class, and in some other cases, the DERM system need to send controls, and that controls from the site gateway will be passed down to the inverters as schedules. So that is generally termed as the control in DER or SunSpec communication. So that's also handled in separate classes. And here in SunSpec Modbus, there is an option to exclude or include parameters or classes based on your requirement. So that means if a vendor would like to provide certain information, they can have or include that information in the class. And if they cannot provide or opt out to provide, then that can be excluded. So that functionality is also available. And the protocol provides a capability of discovery. So that means the Modbus Master or SunSpec Modbus Master can discover the downstream device and find out which all points are available in the downstream meter or inverter. As you can see, the protocol is commonly used in meters and inverters, not in the SCADA systems. And here, SunSpec Modbus Master can test the communication with SunSpec devices. That's the main feature that we are trying to talk about today. And on other note, to support the testing on the other side, the DERMS ASE 2000 also supports 6 IEEE 23.5 client to test communication with the DERMS system. These are some of the highlights of SunSpec Modbus. And now we can focus on SunSpec Modbus capabilities in ASE 2000. So at this point, we only have the master capability. It allows, the tool can allow user to discover the models available in remote SunSpec device. That means if you have an inverter or meter, you can connect to the inverter and discover it. You don't have to create the point list upfront in your master. To start the testing, you can discover and find out which all points are available in the remote device. And further, you can also find out the models. In addition to models, you need the data points available in specific models. So again, this is also an optional thing in SunSpec Modbus. And in some cases, in the older protocols, you need to find out which all data points are available, and you need to manually configure them. But to take advantage of the discovery, we have provided the feature to discover the data points also from these models. And rest of the things are straightforward. Then we can read the data from the models. So these data can be telemetry data or the control data available in the device right now. So those information can be read using exchanges. So you can periodically read the telemetry data to simulate a site gateway. So site gateways will be normally pulling the data at a periodicity, say 30 seconds or higher interval. So that can be simulated using ASE 2000, and other capability is the write of the schedules. And for that, we support the write feature, and user will be able to select the data points which are writable, and based on the discovery can we can do that. So yeah, these are some capabilities in ASE 2000. Finally, I will yeah, this is the last part of our webinar where we demonstrate the tool. So I'll switch to the, I'll exit the presentation, and um, I'll start the tool. Okay, when you start the software, you will see mostly the binary protocol. And if you browse to the select protocol option, you can select SunSpec Modbus or Modbus serial. So serial or TCP options are available. So if you have a serial SunSpec Modbus device, you will be able to use the serial. And if you have SunSpec Modbus TCP device, then you can use this TCP option. So to make the things easier, during the demonstration, I will use the TCP. And once you select the protocol, you will be able to see these default exchanges like read model list, read model point list, read model points, and write data points. So these are the 4 exchanges available. And advantage of this approach is that you can discover the models in the remote device. You can read, you can identify and discover all the data points in each models, and then further, based on your requirement, you can read them or write them. So these are the basic 4 capabilities available. And to go further, I will explain how to configure the system. So if you go to the tools, properties, you will be able to see the standard interfaces like communication, display protocol and other tabs, and in the end you will see SunSpec Modbus TCP option. And here you can specify whether you'll be using which IP address and port number for the SunSpec Modbus, and there is an option to specify the base address of the Modbus device. Generally, it is if it is star, if you configure star, then tool will try to poll all the possible combinations. Like most commonly found combinations are 0, 40,000 and 50,000. So tool will try to do that, but you will also be able to kind of select one of these if you already know the device base address. And further, there is a capability to apply the scale factor. This will be useful for the data points where the scale factor is relevant. Based on the scale factor, it will do the multiplication, and when it reads any data from these devices, the raw values will be scaled based on the scale factor if you check this option. And you can do the same thing if you when you write. So that means if this option is not selected, then the raw value will be displayed when you read, and when you write, whatever values are entered, those values will be returned directly to the device. But if you apply scale factor, then tool will automatically adjust the values before writing or reading into the device. Other capabilities are in the case of writes or schedules. So there is a enable feature. That means the data is written into the SunSpec Modbus device, and later there is an additional enable data point that need to be written to apply that write. So we provide options to either send the enable after the command or before the command, because in some devices we have noticed that this enable point should be written before the command. So usually, after command is the most common behavior in most of the devices. So that's a default. And if you want to change it, you will be able to change it here. So these are some of the features available. And to start the demonstration, I have a SunSpec Modbus simulator running. It's a basic simulator that we use for our development testing, and we will utilize that to demonstrate the capabilities. And in that simulator, we have loaded two SunSpec Modbus classes, and we can see how they are discovered. And for the demonstration purpose, we have used the device ID 1. So I'll set the device IDs in all these exchanges. So if you have multiple devices, you will be able to kind of specify whatever device ID you have. And all these exchanges are copy pastable. That means if you want multiple of these functionalities, especially if you want to group some of the telemetry reads together, you can instantiate additional exchanges here. You can change the name also. For example, if you want to kind of set the telemetry read, you can do that. So you can kind of rename the exchange and make it more readable. And if you want to read some values from the controls, you can kind of set those information here. So this will allow you to kind of make the exchanges more readable and identifiable. And you can drag and drop to change the order to make it more meaningful for your display and testing. Okay, so I'll first go with the read model list. So here, if you go to the exchange properties, you can see that the device ID is already 1. I had set it here. And further, we have a prefix or SunS. SunS is the prefix available in the device. So right now we don't have any other models available. So first we will try to discover the model from the remote device. So there are some options available here, like you can select the transmit flag and use the play button if you want to run a longer simulation. But in this case, for the demonstration, I will use the once button, so it will trigger the functionality once. Okay, so in this exchange, you can see that the line monitor will be displaying you all the hex values in the protocol transaction, and on the right side you will see the interpreted values or interpreted information provided by ASE 2000. And you will also have the messages view. So that means if you want to drill down further into those messages, you will be able to go deeper. And here you can see that the SunSpec header is verifying, and then further we have some other information. Uh, yeah, here you can see there are certain counts being retrieved. So all this information you can drill down into the messages and find out. And here you will see the interpreted view. So here you can see that the model list is being retrieved for a specific model 701 and 707, and we are also trying to get the information of length of the model, how much data is occupied in this model, that is also retrieved. So it's more like a discovery process here. Once this discovery of models is completed, then uh, you can see that the list will be populated with all this information. Like you can see here that after sun s, which was the only entry available earlier, and now we can see the 701, which is the DER AC measurement class. This is the telemetry class available in SunSpec Modbus, and if you select that and go to the properties, you'll be able to see that the size of this class as seen by the discovery process, and the ID of the model. And further, you can also see an additional model called trip LV, and here also you'll be able to see this similar information, like what is the size of this model and what is the offset. So this information will allow you to find out what are the models that are available in the remote device. Once you do the model discovery, then the next process will be the models points discovery. That means you need to find out which all points are available in each of these models. So we can follow the same process, trigger the discovery process. So here the discovery gives you the entire information from the remote SunSpec device. You can see that we invoked a lot of transactions, and we got a lot of information back from the device. So here in the discovery process, we already know the register addresses of the 701 class and the 707 class, right? And further, device will try to pull the information, and we can see here that the Modbus Master or the ASE 2000 as the Modbus Master polled the device and got all the information. So that means we got good quality for most of these register values, and those will be tagged in the registers. So here you can see all these informations are kind of retrieved, and using this process, tool identifies which all points are available in the remote device, so that it can mark them accordingly. So here, if you further go into the models point list, after executing this exchange, you'll be able to see that all these data points will be filled with the point ID and the quality. Before executing this discovery, you will not have this information updated. So that means most of these values will be invalid, and you won't be able to kind of see these details here. But yeah, once the discovery is completed, then all the data points will be updated correctly with the value and quality. So right now, most of the values are not set in the device, and that's why we are seeing them as default value. So here AC wiring type is value is a single phase, and apparent power the value is 0, and so on. So these values are kept to default, and that's why you don't see them as zeros. And once this model discovery is done, then you'll be able to see the list of data points in the point list. Earlier, this point list was blank, and now after the discovery process, you'll be able to identify the class and the registers here. So on the left side, we are seeing the point IDs corresponding to each of these registers in the remote Modbus device, and the name indicates the SunSpec Modbus naming of the device. So that gives you much more information than a standard Modbus data point by giving you the full description of the data point. For example, here in 701, total AC current, right? This we already know that this is it indicates the current value in the device. Similarly, we have voltage here, we have the total energy injected. All these are descriptive information for to easily identify the data points in the remote device. And to go further, I'll select a few data points that we can read. And for that, I will go to the edit exchange properties for the telemetry exchange. As I mentioned earlier, this is just a text. We can add any suffix to the suffix, or even change the name of the exchange to match it with your requirement. And to select the data points, you need to select the model, and further all the data points that are available in that model will be displayed in the drop down or pick list. And here for the demonstration, I will show the active power and reactive power. So if you go to the active power, you can see that there is a value already read. It is 1201. As part of the discovery, it will read the value. So we already have the value here, and reactive power also has some value 1890. So we are not simulating any values in the simulators. Now I will show how the data point read will be invoked. So if you do the telemetry read, you can see that the data point is read, and we can also see the value here 1201 and with a good quality. And similarly, you can also see the data point reactive power, and that is read with 1890 with good quality. So using this method, you can kind of read the telemetry points or any points that you want to configure and monitor. You can keep on running it, and the tool will be able to pull the information over and over again. So like this, it can read the values. And if the Modbus simulator is supporting the changes, or in the actual device, these values will be fluctuating or incrementing based on the actual active power and reactive power. So you'll be able to see them updating in the point list and the line monitor. So if you go to the point list, you can spot the value. It will be under 701, and I'll try to identify that device here. So, okay, there are a lot of points in this list. So yeah, here. So you can see that all the data points are in the grayed out form. So unless the data points are red, it will not be active. It will be shown in a slightly different font if the values are polled. So using this method, you will be able to poll the values from the device. So raw values and scaled values will be available. And if the scale factor is applied, you can see a different value here. Let us read one control point. For the demonstration purpose, I will select one control point, but in the actual scenario, you can configure any number of control points for the write and read. So we'll use adopt curve request. I'll select OK and trigger a read operation. So you can see that the analog value is 135 right now, and we can select the same value in the write exchange. So this will allow you to select multiple data points and configure the write. So if you go, so I have this adopt curve request here as well, and I'll select. So here for the write operation, you will have to set the enable tag after selecting the data points. So in this case, we have only one point, but even after that, you will have to select a enable write data point. But you will be able to select multiple points as you want. That is, yeah. So if you, that option is already available. So you may set a value, say 145, for example, and you will also have to set the enable tag. By default, it will be disabled, so you can enable it. So we are trying to change the value from 135 to 145. So click OK and trigger the exchange. So once you trigger the exchange, you will see the status of that exchange. Right now, write is success, and you'll be able to see it here. And further, if you read the value back from the SunSpec device, you can see the updated value here. So I have only shown very basic capabilities, but in reality, you can read the entire device. So here in the simulator, we have adjusted the model in such a way that it doesn't have a lot of classes like in a standard inverter or meter for the demonstration purpose. But in a real inverter, you might see more classes than this, and it will help you to kind of navigate through the entire classes and allow you to do the telemetry and controls for any of those points as required. Yeah, I think this is pretty much the basic capabilities. And here you will be able to copy paste all these exchanges and change the device ID. So for example, if you want to configure multiple devices, you'll be able to specify the channel. Here you can specify the IP address of the device and the port number and the device ID. So in this case, we only have one device and it is only available in the loopback address. That's why we don't have to specify the channel. But in reality, if you have multiple devices, you can configure those as channels here as IP address and port number and poll them in parallel. So that means at the same time, you'll be able to read data from multiple SunSpec Modbus devices using ASE 2000. I think, yeah, I think that pretty much covers our demonstration. Yeah, I
So
think,
like in ASE 2000 for conventional SCADA, will users be able to define multiple exchanges such as write operations followed by read operations in a sequence and be able to save that?
yes, that option will be available. So user can kind of create any number of exchanges and set the data point. Say, for example, here, if you like to select a different point for the write operation, then yeah, you can do that and save it here. Yes, so you'll be able to assign any name, any names to it for better identification. So yeah, you can sequence the exchanges accordingly.
And that test sequence can be saved?
Yes, you can save these exchanges and open this anytime later. Yes.
So how do we share user instructions for 2030.5 testing with ASE 2000?
Uh, so here for 23.5, we will have to use the X protocol. So I'll open one more instance and show the basic exchanges of 23.5. So I'll open up another instance, and here if we select the protocol IEEE 2030.5, you'll be able to see the corresponding exchanges. So you can see that 23.5 has got more capabilities to read the data points from the server, then read the end device list. So here the concept is slightly different compared to the standard SCADA protocols. So here server in 23.5 need to have the device listed, and site gateways will find out whether the server is configured with the 23.5 device as end device, and update data into that. So that's the process followed uh, in this protocol. And to facilitate those communication, we have several exchanges. There was a separate webinar done to explain the details, and we can see that all these capabilities are available, and you can refer to that previous webinar to understand how 23.5 work. And on top of that, we can also refer to the user manual provided along with the tool, and there is a separate protocol section for both the SunSpec Modbus and 23.5. So you can refer to those sections and understand how each protocol can be used from a user perspective.
So if OEMs want to evaluate our tool, what is the process to do so?
Yeah, so they can download AC2000 from our website, and see here, if we go to our website, yeah, I'll share my screen. They can navigate to the support and download section and go to AC2000 testset and driver downloads. So here under software download, they can navigate to that AC2000. And if a user has not registered in our website, they will have to register first and get the login. Once they have the login, they will be able to download the latest features, latest versions from our testset. So here they can go for this latest release version and download the software. Once the software is downloaded, it will ask for the license. So for the licensing purpose, uh, so you'll be getting a window like this, and here you will have to request for the trial license. So once the trial license request is made, uh, yeah, then you need to enter all these details and select the tools that you want to evaluate. Once the request trial license is sent to the server, we have a portal that listens to the request from different users, and the portal will automatically issue a license. And once you get the license in your email, you will be able to install the license using this option. So you save the file from your email and browse that file here in the install license process. So yeah, once that is done, you will be able to evaluate the tool for 30 days, and based on the feedback from evaluation, you may proceed with purchase as required. So that's the general process to get the tool evaluated. Yeah, I can see that we are running out of our time, right? Yeah, we initially planned for 45 minutes, but now we are already at 50 minutes. So any questions at this point? I think we can, yeah, we have any further questions, we can address those now. We have pretty much covered the demonstration.
I'm not seeing any
Okay.
additional questions in chat.
Yeah. Yeah, I see one question. Yeah, I see that yeah, one user has asked why SunSpec Modbus RTU capability is not implemented in our tool. Okay, so I can answer that quickly. So here, AC2000 is more like a troubleshooting and testing tool, and uh, we are yeah, definitely many protocols can be simulated in AC2000, but since we are introducing this protocol for the first time, we thought of launching it with the master or client capability. So that means SunSpec Modbus Master uh, is available in serial and client is available in TCP mode. And using this capability, you will be able to get the model and test the downstream meter and inverter devices. But going forward, based on the interest from market, we will be able to support the um, RTU mode as well. So one of the key highlights of AC2000 is the monitoring mode capability. That means you can listen to the traffic between master and RTU and see the issues. So we will be implementing that soon once we have enough interest from the market. Yeah, based on the feedback, we'll be proceeding with those developments. Uh, Other question I see is the why this is not available or whether it is available in the task mode. Uh, so uh, So yeah, here the point I want to highlight is that the scalability. So scalability feature is only available in the RTU. Sorry, the in the exchange mode. So that's why we thought of covering the exchange mode first, and based on the interest from market, we will support the task mode in future. So yeah, these are the questions I see, and I see another question. Are you certified by SunSpec? No, our tool is more like a testing tool and simulating tool, and we provide a lot of capabilities to simulate invalid data and generate errors and so on. And also, our tool is not um, aware of the data values. For example, if you read actual SunSpec device, you will expect certain values available in the telemetry points, control points, etc. So here we provide full flexibility to the user to configure them, and because of that, some of the data may not be meaningful unless you configure them properly. So yeah, so being a testing tool, we don't have certification. Other question, um, other question I see is that um, how fast in data transmission in multiple MFMs in SunSpec Modbus. Okay, so assume that we are the person was trying to understand the data traffic in the SunSpec Modbus devices. So generally, the polling of the SunSpec Modbus is done at a rate of 30 seconds or 1 minute based on the utility requirements. So yeah, but SunSpec Modbus also is a it's built under the Modbus, so that means the polling mechanism will have to be deployed. So I assume that that's the question, intended question. And the next question mentioned is the what is the maximum number of MFMs in one SunSpec Modbus link? Uh, I'm not a protocol expert, but I assume multiple device IDs can be specified under one Modbus port. So that means you'll have a TCP port or serial port, and under that, like DNP3, you can have multiple link addresses and specify um, multiple devices there. But in case of RS485 communication, which is a multi-drop communication, you will have to comply with the RS485 cabling requirements, and yeah, the register itself, like if you look at the device ID, it can support generally 255 or around that, but there will be a practical limit of devices that can be available in one channel. For example, RS485, if you keep on polling the devices, and if there are too many devices, you won't be able to poll at a faster rate. So you'll have to look at the practical scenarios and deploy the devices accordingly. Then the next question I see is that how reliable is monitoring and controlling the remote station field equipment? So generally, these connections, as I mentioned earlier, are managed by the site gateway over cellular links. So cellular connections is connection mode is used by the site gateway to establish connection with the DERMS, and DERMS will continuously get these updates like telemetry updates from the field devices. So these, because of 5G networks across the world, then you can see that it's a pretty reliable communication. And 23.5 supports permanent connection if required. That means protocol is designed for intermittent connection failures or yeah, interval-based connections, but it also supports permanent connections. Some utilities demand the permanent connections. Here in California, we are using permanent connections unless there is a cellular network problem. The connections are retained from the site gateway to the DERMS system. So the connection is very reliable over the 5G or 4G networks or LTE networks, and you'll be able to get the monitoring and controlling done as if it is a SCADA protocol. The next question I see is that is there any third-party tools to check the mode scan of SunSpec Modbus data in respective read-write registers? So I think the user was or the participant was asking about a software that is similar to mode scan for SunSpec Modbus. I'm not sure about that. So mode scan can be used over SunSpec Modbus, but only thing is that you won't be able to find out the meaningful information like I shown earlier, right? The point list is populated with the names of each and every tag. So this kind of information cannot be displayed in mode scan kind of software, I assume. And I'm not aware of any other third-party tools in the market that can do this. Okay. So yeah, looks like, yeah, these are the questions I see. Yeah, I don't see any more questions here. Yeah, if you have any more questions, then feel free to send to us, and we'll be able to support you in the process. And if you need any training or familiarity with the AC 2000, definitely we can support you in that process as well. Okay.
Thanks for the demonstration and detailed explanations, Darren.
Yeah, you're welcome. Yeah, looks like we don't have any more queries. So shall we close the webinar?
Sure. Yeah.
Yeah.
Thank you so much. Thanks, Darren. Thanks, Larry.
Okay.
And thanks
Thanks.
everyone for
Thanks everyone
participating.
for attending the. Bye.